The learning goals for Lesson 10 are for you to understand and apply extended ranking procedures for all types of voting, to understand recursive ranking procedures for all types of voting, to identify approval voting, which is a type of non-preferential voting, and to use approval voting to determine the outcome of an election. As usual, we'll start with a brain activator. Abby, Bethany, Cedric, and Dylan are in the running for a seat on the Student Senate. The election is held using a preference ballot. The preference schedule is shown. Notice that the letters in the preference schedule relate to the initials of each one of the candidates. The Elections Committee is going to use pairwise comparison to determine the winner. 1. How many possible pairs are there? And 2. Who is named to the Student Senate? Please pause the video as you work on this problem. You will want to use the handout that has the brain activator on it as you begin to work. Now let's do a quick check. The first question is, how many possible pairs are there? As you'll recall, we know that for n candidates, the number of possible pairs can be found by using this formula. N times the quantity n minus 1, all divided by 2. In this case, n is equal to 4. So using that, we can substitute 4 in place of n. We get 4 times 4 minus 1 divided by 2, which equals 4 times 3 divided by 2, which equals 12 divided by 2, or 6. Now for the second part, we want to know who is named to the Student Senate. We've determined that we have 6 pairs that we need to check in a head-to-head matchup. So we're going to do head-to-head matchups for A versus B, A versus C, and B versus C, A versus D, B versus D, and C versus D. Those are our 6 pairs. The first head-to-head matchup that we're going to do is Abby versus Bethany. As we look at this particular table, we can see that in the first ballot that's shown, where we have 14 voters who voted this ballot, Abby is ahead of everybody. She has the first place. But then notice with this ballot, Abby is 4th place. And for the next one, she's also 4th place. She's 4th place and 4th place. So the only place that Abby outranks anybody is with the set of votes that we know are 14 ballots. So we have 14 for Abby, and Bethany has all the rest of the ballots for a total of 23. We need to keep sort of a scorecard of the results because Bethany has a point, and we're going to put those points on our little chalkboard up here, and now we've given Bethany a point. Going to the next matchup, we have Abby versus Cedric. The same situation applies. Again, Abby is only in first place on one set of ballots, and everywhere else she's 4th place, so we'd have the same result, and we can see that we're going to have to give Cedric a point. Now, go into Abby versus Dylan. The same situation applies, and we know that Dylan's going to get a point. The matchup against Bethany and Cedric be next. As you look at these columns, Bethany is ranked higher than Cedric in the first ballot and in the 4th ballot. And notice that there were 14 voters with the first ballot and 4 with the 4th. So that gives us a total of 18. Cedric has outranked Bethany in the ballot that had 10 votes, the ballot with 8 votes, and the ballot with 1 vote, giving Cedric a total of 19. A close race, but Cedric earns the point, and we added that down to our tally on the chalkboard. Next we have Bethany versus Dylan, and looking at each of the columns we can see that Bethany did outrank Dylan on the first ballot, so that's 14 points. On the second ballot, Bethany outranked Dylan, and so there were 10 votes on that particular ballot. As we look at the next column, we see that Dylan outranked everybody, so he's going to get the 8 votes there. On the fourth column, Bethany outranked everybody, so she's going to get 4 points there. And then on the last column, we see that Dylan outranked Bethany, so he gets the 1 vote there. That means that the total for Bethany is 28 and for Dylan is 9, so the point goes to Bethany. We've already looked at 5 of our pairwise comparisons. Now we have to do the last one, and that's going to be Cedric versus Dylan. So we're looking now at each of these columns, and we can see Cedric ranked higher than Dylan in the first ballot. There were 14 votes, so the 14 go with Cedric. And in the second ballot, Cedric outranked Dylan again, so all 10 of those votes go to Cedric. But in the third column, Dylan outranked everybody, so he gets the 8 points. In the fourth column, Dylan outranked Cedric, and so the 4 votes there go to Dylan. And finally, in the last column, we see Cedric outranked everybody, so he gets that 1 vote. Adding all of those together, Cedric has 25 votes, Dylan has 12, so our mark goes by Cedric, and because Cedric has 3 tally marks, 3 points, he would be the winner. He would be named to that student senate seat. This is the final lesson for the Mathematical Decision Making Edmodo group. This particular portion of Lesson 10 considers methods for ranking candidates. Sometimes it is really easy to tell who the winner of a race is. There's a clear front runner and everyone knows that person will win. But is it enough just to announce the top spot? Is it ever necessary to indicate the rankings of all the other candidates? One scenario where ranking, at least for the first few positions, is important is a beauty pageant. The contestants and the audience are interested to know how each candidate ranked in comparison to the others, and naming the runners-up is important as well. Another place that ranking candidates can come in handy is Civic Club officer elections. Many clubs have people who are interested in being an officer simply run for a place. The person with the most votes is elected president. However, the second place person becomes vice president, third becomes treasurer, and so on until all the positions are filled. We're going to look at 2 different ways to rank candidates in an election: extended ranking and recursive ranking. For this lesson, we'll be investigating each of these ranking methods. Both can be used with any form of voting. However, for ease of example, I will use the plurality method to demonstrate. As a reminder, in plurality voting, voters indicate their top choice to win. The person that receives the most votes wins the election. Extended ranking is a ranking method that extends a voting method until all candidates are ranked based on their performance in a single vote. If you define the term extend as to lengthen, you will have a good idea of the process of the extended ranking method. The extended ranking method takes a traditional voting method and just lengthens the process until every candidate has a rank. It is the simplest procedure for ranking each of the candidates or options or alternatives in an election. Regardless of the particular voting method, the idea behind extended rankings is the same. First, run the election using a particular voting method. Second, rank the candidates or alternatives based on their performance on whatever measure the particular voting method uses to determine the winner. This is best seen by observing an example. Let's first look at extended plurality. Under the plurality method, only first place votes count. We're given a preference schedule which represents an election among George, Holly, James, and Ingrid. And we're asked to rank the candidates using the extended plurality procedure. Because we're only looking at first place votes, we can rank our candidates in order based on the number of first place votes they received. Looking at this, we see that George had 13 first place votes, Ingrid has 12, and James has 10. But Holly doesn't show up at all on the first place list, so Holly has 0 first place votes. Now we're going to do an extended ranking, and we can see that these really are already in order. George is first, Ingrid is second, James third, and Holly fourth. This is how you would do extended plurality. Now let's look at an extended board account. This preference schedule is the same as the one we saw before. Our instructions this time are to rank the candidates using the extended board account method. Remember, with the board account method, we're going to look at how many places there are, and we're going to assign points based on the place. So the last place would get 1 point, the next to the last 2, and so on up until we get to first place. So first place in this instance would get 4 points. Let's look at the board account number for each of our candidates. For George, we see that he has 13 first place votes, so we're going to multiply that by 4. He also has 10 second place votes, so we're going to multiply that by 3. And as we look at third place votes, George is not listed here at all, so we're not going to multiply any number by 2. And then finally, for fourth place votes, George has 12. Multiplying 1 times 12 will give us 12. And as we do the arithmetic here, we see that George has 94 as his board account. Let's look at Ingrid. Ingrid has 12 first place votes, so we're going to multiply 12 by 4. And as we look down the other rows, we see that Ingrid is not listed until we get to fourth place, and there she shows up twice, 13 plus 10, and so that's where this 23 comes from. Adding those all together, we get 71 as the board account number for Ingrid. Next is James. James has 10 first place votes. We're going to multiply that by 4. Looking at row 2, we see none, and then looking at row 3, we see that James has 13 plus 12 third place votes, and third place votes get multiplied by 2, so that's 2 times 25, giving us a total for James as a board account number as 90. Now finally, Holly. Holly has no first place votes, as we can see, but she does have second place votes. In fact, she has 25 of those, and second place votes are multiplied by 3. And then looking at third place votes, Holly has 10 of those, and they are multiplied by 2, giving Holly a total of 95 as her board account number. So we've found the board account numbers, and we're going to rank those by those totals. So the extended rankings are: Holly's going to be in first place with 95 as her count. George is in second place with 94. James is in third place with 90, and Ingrid comes in fourth with 71. Let's next look at extended plurality with elimination. This is the same preference schedule that we've seen for the last two methods, and in fact it has a lot in common with the very first one we observed, which was extended plurality. I've left the information over to the left of the preference schedule. Remember when we ranked all of our candidates in order of first place votes. And we can tell that on the extended rankings that Holly is in fourth place because she had the least number of first place votes. With plurality with elimination, as you'll recall, we eliminate the person who has the least number of votes, or in certain cases it might be the option that has the least number of votes, and then we move any candidate who's beneath the eliminated candidate up. And so you can see we have moved up all of our candidates that were on the fourth row. Now, as we look at this, we still have the same order because it didn't affect our first place votes. We still have George with 13, Ingrid with 12, and James with 10. So the next least number of votes goes to James, and that puts James in third place. We're going to now eliminate James, and we're going to move up any candidate that's beneath James. We're left with two candidates, and we can tell that George has 13 plus 10 first place votes, giving him 23, and Ingrid has 12 first place votes, and so that puts George in first place and Ingrid in second place for our extended rankings. Finally, let's look at extended pairwise comparisons. This time, when you look at our preference schedule, you'll see that it is a little bit different from the previous three examples. The mayor of Smallville is being chosen in an election using the method of pairwise comparisons. The four candidates are Paul, who's represented with a P, Rita, represented with an R, Sarah, represented by S, and Tim, represented by T. We're told to rank the candidates using the extended pairwise comparison procedure. The first thing we need to do is to determine the number of pairs that are possible for putting into a head-to-head matchup. We did this with our brain activator. As you recall, the number of pairwise comparisons within candidates can be found using that formula, n times the quantity n minus 1 divided by 2. In this particular case, we have 4 candidates, so our n is 4, and we can substitute 4 in place of n and determine that there are 6 possible head-to-head matchups. We want to list all 6 of them and then go through each pair to determine which candidate would get the point. So as we put Paul against Rita, we'll see that Paul has 130 votes to Rita's 370. Again, very quickly, looking at the first column of votes, the first ballot, Paul is ahead of Rita, as you can see. So those 130 votes go to Paul. And then as we look at the second ballot, Rita is ahead of Paul, so all 120 of those votes go to Rita. Looking at the next ballot, Rita is again ahead of Paul, so the 100 votes here go to Rita. And finally, in the last ballot, Rita is ahead of Paul, so those 130 votes go to Rita. Rita now has 370 to Paul's 130, and so the winner in this particular matchup is Rita, and Rita would score a point. Going to the next matchup, Paul versus Sarah, we would very quickly go through and do the very same thing. Paul has 230 votes, Sarah has 270 votes, meaning that Sarah gets the point. In our next matchup, Paul versus Tim, we can see that Paul is ahead of Tim in 2 particular cases. So Paul gets 130 plus 150, or 280 points. Tim is ahead of Paul on the other 2 ballots for 220 points. Paul gets the point. Now, in the matchup against Rita versus Sarah, we can see that the only place where Sarah is ahead of Rita is in the last ballot, and therefore Sarah's number is 150 compared to Rita's 350, and Rita gets the point. In the matchup Rita versus Tim, we see that Rita has 280 points to Tim's 220 points, and therefore Rita gets the point for this matchup. And the final matchup is against Sarah and Tim, and we can see here that Sarah gets 280 votes and Tim 220 votes, giving the matchup to Sarah. As we look at these now, we can see and sort of sort through who has the most. And in doing so, we see that Rita has 3 points, Sarah has 2, and Paul has 1. And so the ranking order for this particular matchup would be Rita first, Sarah second, Paul third, and Tim would come in fourth. We've spent time on extended rankings. Let's turn our attention now to recursive rankings. Regardless of the particular voting method, the idea behind recursive rankings is the same. Run the election using a particular voting method. The method can be plurality, plurality with elimination, border count, or pairwise comparisons. The winner of this election is assigned first place. Now we're going to remove that winner and rerun the election using the same voting method. The winner this time is assigned second place. We're going to continue this procedure, rerunning the election and assigning places to the winner until all candidates have been ranked. Let's look at recursive rankings with each of the voting methods that we've discussed. First of all, recursive plurality. We'll run a plurality election. First place goes to the candidate with the most first place votes. This candidate is eliminated and the election is rerun. The winner of this second election, the remaining candidate with the most first place votes, gets second place. And you're going to repeat this process, eliminating candidates and rerunning elections until all of the candidates are ranked. For the recursive border count, you would run a border count election. First place goes to the candidate with the largest border count total. This candidate is eliminated and the election is rerun. The winner of this second election, the remaining candidate with the largest border count total, gets second place. And you repeat this process, eliminating candidates and rerunning elections until all of the candidates are ranked. For recursive plurality with elimination, you'll follow the same steps. Run a plurality with elimination election. First place goes to the lone remaining candidate. This winning candidate is eliminated and the election is rerun. The winner of the second election, the lone remaining candidate after the elimination process, gets second place. And we repeat this process, eliminating candidates and rerunning elections until all of the candidates are ranked. For recursive pairwise comparisons, we're going to follow the same procedure. Run a pairwise comparisons election. First place goes to the candidate that wins the most head-to-head matchups. Remember, we give 1 point for each head-to-head win, half of a point for each head-to-head tie. This candidate then is eliminated and the election is rerun. The winner of the second election, the remaining candidate that wins the most head-to-head matchups, gets second place. And we repeat this process, eliminating candidates and rerunning elections until all of the candidates are ranked. Because recursive ranking requires repeated elections, we're not actually going to go through any examples of these, but I do want you to understand the process, and I think by looking at all 4 of the voting method types, you can see how they would work and how they all relate to that general pattern. Now let's take a moment to look at approval voting. As you'll recall, we have studied preferential voting methods, which include the plurality method, the method of plurality with elimination, the border count method, and the method of pairwise comparisons. We've only talked briefly about the non-preferential voting method, in that we did say that there is one type that we're going to focus on, and this is the lesson where we're going to have an opportunity to do that. And that one type is approval voting. But before we get into that, let's just review what non-preferential voting is. Non-preferential voting methods are those methods that do not use information from a preference schedule. We'll look at one non-preferential voting method to provide a contrast to the 4 preferential voting methods that we've covered. This non-preferential method is called approval voting. Approval voting is a voting procedure in which voters can vote for as many candidates as they wish. Each candidate approved of receives 1 vote. The candidate with the most votes wins. In this mock ballot, you see it says vote for 1 or more candidates. The candidate with the most votes wins. This particular person has not shaded in beside Eleanor Roosevelt but has selected Chavez, has not selected Lum, has not selected Hancock, selected King, and selected Aquash. So even though it's one ballot, there are 3 votes on here, and they are not ranked in order. They're not a 1, 2, 3 kind of situation showing a preference of one of these over the other. So what's going to happen is we're going to have all of our ballots come in and then tally up each person's number of votes from those ballots and determine a winner from that. Let's look at the advantages of approval voting. Approval voting gives voters more flexible options. With approval voting, voters can do everything that they could do under plurality voting, but if they have no strong preference for one candidate or another, they can express this fact by voting for all candidates that they find acceptable. In addition, if a voter's most preferred candidate has little chance of winning, that voter can vote for both a first choice and a more viable candidate without having to worry about wasting a vote on the less popular candidate. Approval voting helps elect the strongest candidate. Today, the candidate supported by the largest minority often wins, or at least makes the runoff if there is one. Under approval voting, by contrast, the candidate with the greatest overall support will generally win. In particular, Condorcet candidates, who can defeat every other candidate in separate pairwise contests, almost invariably win under approval voting, whereas under plurality voting they often lose because they split the vote with one or more other centrist candidates. It also reduces negative campaigning. Approval voting induces candidates to try to mirror the views of a majority of voters, not just cater to minorities whose voters could give them a slight edge in a crowded plurality contest. Thus, it is likely to cut down on negative campaigning because candidates will have an incentive to try to broaden their appeals by reaching out to voters who might have a different first choice, without alienating them. Approval voter increases voter turnout. By being better able to express their preferences, voters are more likely to vote in the first place. Voters who think that they will be wasting a vote or who cannot decide which of several candidates best represents their views will not be forced to make a single, perhaps arbitrary decision. This in turn makes it more likely that this voter will go to the polls. It gives minority candidates their proper due. Minority candidates will not suffer under approval voting. Their supporters will not be torn away simply because there is another candidate who, though less appealing to them, is generally considered a stronger contender. Because approval voting allows these supporters to vote for both candidates, they will not be tempted to desert the one who is weak at the polls as under plurality voting. So, minority candidates tend to receive votes which reflect their true level of support. And finally, it's very practical. The idea itself is very simple, unlike many other voting schemes, and can readily be implemented on existing voting machines. Let's take an example of approval voting. In this particular example, we see that we have a first period high school physical education class, and they've decided to take a vote to determine which activity that they will take up next in PE. Their choices are aerobics, badminton, football, or softball. The winning activity will be determined using approval voting. Suppose the following summarizes the responses of the class. 12 students vote for aerobics and badminton, 5 students vote for badminton, football, and softball, 10 students vote for football and badminton, 13 students vote for softball and badminton. And we want to determine the winning activity, so we must calculate the number of votes received by each activity. The activity with the most votes wins. We know that we have this particular set of votes, and so let's go ahead and put them in our table so that we can determine what activity will be the winning activity. So we know that we have 12 students for aerobics and badminton. We have 5 students for badminton, football, and softball, 10 students for football and badminton, and 13 students for softball and badminton. And it should be obvious at this point that badminton is going to be the choice. As we add up all of the votes, we can see that yes, indeed, badminton has 40 votes, and so using this particular method, the approval voting method, badminton would be the activity that we do next. Let's look at another example. The second period class votes to choose from among the same 4 activities, aerobics, badminton, football, and softball, but decides to use the board account method rather than approval voting to select their next activity. So we have this preference schedule for second period PE. Which activity is selected by second period using the board account method? As you recall, when we do the board account method, we have to assign points to each of our places. In this particular case, there are 4 activities, so there are 4 different places, first, second, third, and fourth. The highest place will get the highest number of points. So first place will get 4 points, second place 3 points, third place 2 points, and finally fourth place would be 1 point. Looking at each of the activities, we're going to start first of all with aerobics, and you can see from the table, the preference schedule, that aerobics shows up only in third and fourth places. So we're going to multiply 2 times the number of third place votes, and we're going to multiply 1 times the number of fourth place votes, giving us a board account number for aerobics of 56. Badminton is next. Notice that badminton only shows up second place, and it's second place across the board, so all of those are worth 3 points each, and we'd simply add up the number of votes and multiply that times 3, giving us a board account number of 120. Football shows up in first, third, and fourth places, and so we're going to multiply the first place votes by 4, the third place votes by 2, and of course just add in the fourth place votes because multiplying by 1 just returns that number. And so the board account number for football is 92. Finally, for softball, we can see that softball has 26 first place votes, and it also has 14 third place votes. So to calculate the board account number for softball, we see that it's going to be 132. So if we're doing a ranking of the activities, we put them in order from the one with the largest board account number down to the one with the least. So if we're going to rank these in order, we do softball, followed by badminton, followed by football, followed by aerobics. But the question really is just asking us in this instance, what are we going to do next? In second block, we're going to take up softball. Approval voting has a very nice property. In an election using approval voting, adding or removing candidates or alternatives does not change the point totals of the other candidates or alternatives. As you can see from the last 2 examples, approval voting is similar in some respects to the board account method. Both methods involve computing a total, and the winner is the candidate or choice with the largest total. However, the entire process is much simpler with approval voting. In addition, approval voting is perfectly suited to situations where candidates or choices are added or removed after a vote has already been taken. In an election using approval voting, adding or removing candidates does not change the point totals of the other candidates. If candidates drop out, simply remove them from the list. If candidates are added, vote totals for the original candidates stay the same, and voters only have to give their approval or disapproval of the candidates that were added. As with the types of preferential voting, Non-preferential voting can result in ranking candidates or alternatives. And just as before, the types of ranking include both extended and recursive procedures. First, let's look at extended approval voting. Recall this earlier example of approval voting in which the first period PE class took a vote for which activity, aerobics, badminton, football, or softball, they will do next in PE. We determined that badminton would be the next activity that the class will do based on the approval voting results. Suppose the curriculum requires that all 4 activities must be included in the course at some point during the semester. We can take the approval voting results a step further and rank the activities in order of when they will occur. Badminton first, then softball, followed by football, and finally aerobics. Recursive approval voting is very similar to the recursive rankings that we had with preferential methods. First, we're going to run an approval voting election. First place goes to the candidate with the most approval votes. This candidate is eliminated and the election is rerun. The winner of this second election, the remaining candidate with the most approval votes, gets second place. And we repeat this process, eliminating candidates and rerunning elections until all of the candidates are ranked. Again, because this requires repeated elections, we're not going to look at examples of it, but I do want you to understand the recursive procedure. In this lesson, you have learned to understand and apply extended ranking procedures for all types of voting, to understand recursive ranking procedures for all types of voting, to identify approval voting, which is a type of non-preferential voting, and to use approval voting to determine the outcome of an election. You may go back and look at any part of this video as you work on the assignment for this lesson. Remember that this is the last lesson in this series. Following this lesson, you will be given some review sheets that you can practice for and study for your test over these topics that we have covered. As you recall, initially we looked at identification numbers, then we worked with graphing and the types of graphs that we could use to model networks. And finally, we've worked with the mathematics of voting. So those are the 3 big areas that you'll be reviewing and preparing for the test.